Hi, I'm Dr. Tom for Global Astronomy Month. What do I mean? Whatever you see is as good as it gets. Well, suppose you had a spare billion or two and you could build your own space telescope. Let's have a look at the images from the Hubble Space Telescope. We're in a galaxy called the Milky Way. As you look to its outskirts, away from the center, between the stars, you start to see other galaxies, and more galaxies, and more galaxies, and more galaxies, and more galaxies. In other words, things look pretty much the same. Galaxies and more galaxies. So what about space travel? Well, in the 50s, artists drew what they thought the moon would look like. You can see stars in the background over the mountains. When they finally landed there in the 60s, you could see things are pretty similar, but the stars are missing. You can't see the stars on the moon because of the glare. At night you might be able to see them, but who wants to step out of the space capsule to look? The real reason you can't see things in space is the limitation of our eye. Our eye is a 15th of a second time exposure. So all these time-exposed images you see from photographs don't exist for a human eye. No matter where you went, you wouldn't see them because it's your eye doing the looking. Your eye on a dark night is about 5 millimeters across. Binoculars have 50 times the light-gathering power of your eye. A 200 millimeter, 8-inch telescope has 800 times the light-gathering power of your eye. But if you did a time exposure with those binoculars for 60 seconds, it would have 45,000 times the light-gathering power of your eye. So you can see that those images from the photographs are nothing like what you can see with your eye. Here's the real image. Here's the time-exposed image. But here's what you'll actually see. But do we really want to see these artificial images? Let's take the example of a star on Earth, a Hollywood star. Her dentist can get close up, real close. But don't we lose something in the process? A telescope magnifies, but with a narrower angle than binoculars or your eye. This spreadsheet simulation shows that magnifying an image lets us see more detail, but we may lose the perspective. Which is the better view? Well, both. You need the wide angle and the narrow angle to get a picture. That's why a wide-angle eyepiece is so important for your telescope. The eyepiece can end up as big as a telescope and just as expensive. So before rushing out and buying a monster telescope, consider some of these points. My recommendations: buy some maps. Before you get any telescopes, have a look at your binoculars. If you don't have some, get them or upgrade the ones you have. And there's no one telescope that does everything, so get a wide angle and a high-powered telescope. Get a telescope mounting that's easy to use. As for eyepieces, get a wide-angle eyepiece and a high-powered one for the planets. And most importantly, get away from the city lights however you can. The guiding principles that many other people have put together are: your best telescope is the one you use most often. Get the most expensive telescope you can afford to drop and break. And get the largest telescopes you can afford to take to the real estate you can afford for the time you can afford to view.